Okay, use the figure to find the cosecant, secant, and cotangent. We can find the sine, cosine, and tangent also, but in this case, the secant we know is the reciprocal, or cosecant is the reciprocal of sine. So cosecant 45 is equal to the reciprocal of sine, which is opposite over hypotenuse, right? So what's the reciprocal of 1 over root 2? Square root of 2 over 1. Secant, 45 degrees, is the reciprocal of cosine. Cosine is 1 over root 2, right? But the reciprocal is square root of 2 over 1. Cotangent, 45, we know is the reciprocal of tangent. Tangent is 1 over 1. The reciprocal of 1 over 1 is still 1. Use the figure to find the tangent of 60, tangent of 30. If a radical appears in the denominator, rationalize the denominator. We've done that already, but let's go ahead and take a look at this. So the tangent of 60 degrees, right, is going to be the side opposite over the side adjacent, which is the square root of 3 over 1, or just simply the square root of 3. The tangent of 30 degrees is going to be here, the side opposite over the side adjacent, 1 over square root of 3, which has to be rationalized. Root 3 and root 3 turns out to be the square root of 3 over 3. These are reciprocals of each other. Cofunction identities. So 6 more identities that you need to know. These identities are fairly simple in that they require you to understand a little bit about a right triangle. So let's go back and review. If I have a right triangle, and I know this is a right angle, then I know that angle A and angle B, A plus B, equals 90 degrees. Okay, so A and B we know are complementary to each other, right? So what they're saying is that based on what we just did, that the tangent is equal to the reciprocal of the complement. Remember, we just finished the tangent of 60 equaled 1 over the tangent of 30 degrees, right? So the cotangent, if you remember, is just the reciprocal of tangent. This business of 90 minus theta just means a complementary angle, right? We know that A is equal to 90 minus B. That connection is pretty simple, I hope. We can throw a pi over 2 in there also. It doesn't really matter. Sine of theta is equal to the cosine of pi over 2 minus theta. It means the same thing. So sine and cosine go hand in hand. Tangent and cotangent go hand in hand. Secant and cosecant go hand in hand. And we can flip those around. Cosine and sine, cotangent and tangent, cosecant and secant. So, just to remind you, if this is theta, then we know this angle up here is going to be 90 minus theta. The sum of those angles have to equal 180 degrees. So find the cofunction of sine of 46. Well, 90 minus 46, right, is 44. So sine is equal to the cosine of the complement. So cosine of 44 degrees. We know that the cotangent is equal to the tangent of pi over 2 minus pi over 12, right? Cotangent's equal to the tangent of the complement. We've got some arithmetic to do. This is going to be 6 pi over 12 minus pi over 12, or 5 pi over 12. So we now know that this is going to equal the tangent of 5 pi over 12. Cofunction identities. You'll see them pop up now and again. The regular blue shape in the figure represents a lake. The distance across the lake, A, is unknown. To find this distance, a surveyor took the measurements shown in the figure. What is the distance across the lake? Wow. So we figured out by sight that from A to B was 24 degrees. We were able to measure from A to C directly across the lake, right? So we had a right triangle. So we now know that we want to find A. Based on what we know, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. We are looking at opposite and adjacent. So we want to say tangent of 24 is equal to side opposite A divided by 750 yards. This is now a proportion. We now know that A is equal to 750 times the tangent of 24. We're going to plug that into a calculator. They didn't tell us what to round to, but if we round to the nearest yard, it turns out to be approximately 334 yards. Big key here. Make sure you are in degree mode. Check your mode. Check your mode. If I haven't told you before, check your mode. Okay, so couple of things for the next problem you've got to understand. When you are looking at an object in a word problem, you're always looking from the horizontal. So in this case, you've got the horizontal, you've got the line of sight is right here along the horizon. If you're looking up at an airplane, you've got an angle here of elevation. If you are looking down at the car, you've got an angle here of depression. Looking down is depression from the horizontal. Looking up is elevation from the horizontal. A flagpole that measures 14 meters tall casts a shadow that is 10 meters long. Find the angle of elevation of the sun to the nearest degree. So you're going to have to draw a picture, right? At this point, we are assuming that it was put on a right angle, that the ground is level. That's not always true, but in this case, we're making that assumption. We know that the flagpole is 14 meters. We know that the shadow cast by the sun, do you guys see the sun up here? Sun is shining bright, big ball of yellow. Cast this shadow here. We're looking for this angle of elevation from the horizontal. this is 10 meters. Okay. In this case, we have to use an inverse function. Okay, we're going to say again, our SOHCAHTOA comes into play, right? Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Whoa. Let's try that again. How about cosine is adjacent over hypotenuse? There we go. Tangent is opposite over adjacent. I'm looking for this angle theta. I've got opposite. I've got adjacent. Looks like we're going with tangent. But because we're looking for the angle, it has to be the inverse tangent of 14 over 10. Now we want this in degrees to the nearest degree. So again, check your mode. Check your mode. Make sure you're in degrees. If you're in degrees before, you're probably still in degrees now. So we're going to go inverse tangent and I've got about 54.5 degrees, actually 54.46. Nearest degree would be 54 degrees. So we're just going to say about 54 degrees. Sorry that this was a little long, but maybe you guys can find something in there that's helpful. If not, you may already know most of this. Good luck.